We've seen how we can find missing parts of triangles, of non-right triangles, given some geometry properties such as ASA, SAA. We haven't quite seen SAS or SSS yet, but there's one geometry, I guess, property or theorem that you have always been forbidden from using. And the property I'm referring to is the ASS property, or more likely you'll see it as SSA, right? Because we don't want to see that other word there. So this is a very common property that you might have seen in geometry that your teacher might have said, you can't do that. You cannot use this property because basically, unlike the others, you can't show a unique triangle. And I'm going to demonstrate why this property just didn't hold true in geometry, why you couldn't show that a triangle was congruent using the SSA property or maybe ASS property. Okay, so I'm going to switch over now to Desmos, and I'm going to provide a demonstration for you here. If I can, here we go. Okay, so using this diagram here, what I want to show you is that I have, if you notice here, the angle A in the lower left-hand corner, that's my angle. I also have two sides, so two given sides. You'll notice that B is 4 and A has a side length of 2 as well. So I have an ASS property, just to briefly demonstrate what that looks like to you right here. Right, we have the angle, side, and side property. Where's the side? Well, I'm going to actually show that right here. Okay, so we're going to have the angle, side property. Notice how this angle is not given to us, so this angle can actually change. This side is not given to us, so we don't even know what the side is. You know, it just is formed by whatever forms with this side here, and that's basically it. So I'm going to show you this property here. Okay. So taking a look back over on Desmos now, what I'm going to do is I'm going to say that the A value is a value of 2. Let's say it's like right here. So it's the technically it should be the blue line that you see there. Okay, so it's the blue line that you see here. And so this A value of 2, notice how it is shorter than the 4. Okay, so it's going to be shorter. And what I'm going to do is I'm just going to show you my circle here. Okay, so as I move the blue line, what you can see basically that I'm trying to show you here is that as the blue line moves, you're basically creating like almost like a pendulum swing. And you want to try to get this A value of 2 to basically touch the bottom line. You want to make it form a triangle. However, because that A value is so small, notice how because this is it's a side length of 2, 2 is definitely smaller than 4, which means that side 2 can never actually touch the bottom of the bottom side. So you can't actually form a triangle in this way. So whenever you see that this value, this A equals 2, is smaller than this other side here, you can see that you actually cannot form a triangle, no matter how much you try, as this circle is swinging and trying to touch the other side, you can never form a triangle in this way. Okay. Now I'm going to modify this just a little bit here, and I'm going to now make my A value a little bit longer, so my A value is no longer 2. Okay. And what we'll do is we'll extend the pendulum so we can actually see it expand, right? We'll just see it maybe touch. Let's make it go right around there, right? And what we're going to do is make that radius basically extend further this way, okay? And what we're seeing now is that the A value, as it swings, you still can't form a triangle here, right? It's going along the pendulum, and you can't form a triangle here either, right? But what we end up seeing, actually I need to adjust my my blue line here. Let me do that right now. Let me go here. Sorry, a little bit of behind the scenes work here. Okay, so what I'm going to do now is extend this blue line, and so you'll see as it comes down, remember, picture the dot, and it's trying to touch the black line on the bottom. The only time it can really touch that black line on the bottom is right there, right? Right when it touches at this one exact location, when it is the exact height where the black line actually is. Before that, it's not going to touch. It's actually just a little bit above the black line. After that, again, just slightly above the black line, even though I know that blue dot is really big, it's slightly above the black line, right? You're not actually going to be touching the black line. So the only time it can actually touch the black line is right there. And as it turns out, that's kind of like that one singular spot where it can actually make a triangle, and you can see what kind of triangle you formed there. You're actually getting that right triangle. It actually forms a right angle because it just touches right at that one spot right there. Okay, so that's going to be a way that we can actually form a triangle. But as it turns out, that's not the only way you can form a triangle. That was when you had a particular a value, and that a value just happened to be the height of the triangle. Okay, now if that a value to extend even more, so what I'm going to do is I'm just going to extend my radius of that line. Okay, so I'm just going to go ahead and again, behind the scenes, just do a little bit of modification here, sorry. And this way I can demonstrate to you just what's going to happen as we extend this blue line. So now this blue line is even further, right? And we're going to make this arc even expand further, just like that, right? We're going to make that blue line expand further. And now as I move along the arc, you'll see I'm going to actually touch the bottom line right here. I can actually form a triangle as I come across this arc, and I can create a triangle like this, right? Maybe I did too big of an arc, actually. Let me make this a bit of a smaller arc, something like this, okay? And so you'll see that as I come along this arc, I can actually touch the bottom side and create a triangle like this. Notice how I created a triangle. Looks perfectly fine. And as I keep extending, oh no, I stopped making a triangle because now that line is way too long, right? I cannot make a triangle, cannot make a triangle, cannot make a triangle. Oh, but right here I can make another triangle. You'll notice now I have an obtuse triangle. If you can see the two black lines forming with the blue line right there, I form an obtuse triangle. So I'm able to create a triangle there too, right? But then as I go a little bit further, oh, and I can't form the triangle anymore. But as it turns out, as I was showing you, I can change this radius and I can make different size triangles. I can now make a triangle here, right? I can make the obtuse triangle over here. I can adjust it just ever so slightly, maybe make it like this. And so as this is extending out, I can form a triangle here. I can form a triangle here, like this. So notice how I have a different kind of obtuse triangle now, right? So the idea being that as I made this A side a little bit longer, I was actually able to make two triangles in this case. I have a triangle over here, right on the right side, and as it swings more over here, I can form another triangle, and now that's actually forming an obtuse triangle here. Now, as I had done earlier, if I were to actually extend the arc just a little bit more, maybe more like this, right, I can still form a triangle. I got this arc here. The A is extra long now, and it's going to come down, and look, I form a triangle right there. I got a triangle there, but as I keep going further and further, if that A value is just a little bit too large, what you'll notice is as you come around on the other side, oh no, I can't form a triangle anymore. This blue line is way too long, and it comes past the side length of 4. And so you're not going to be able to form a triangle that way. Okay, so in this case, you actually only are able to get the one triangle that you form in this case here. Okay, so I hope this demonstration helps. I know it's pretty difficult to see online, but I hope this demonstration kind of helps you to see how many kind of triangles you form. And that's kind of what I wanted to show you in your notes if we were in class. Now, in terms of the diagrams that I showed you, basically what I wanted to show you was that you have different scenarios. I'm going to call this scenario 1. And the example that I gave to you there is that you have a side B, you have an angle A, but side A is a little extra small, right? Side A is smaller than side B. And if side A is smaller than side B, then what you end up seeing is that no triangles can be formed. Okay, 0 triangles are formed. In scenario 2, what I gave to you was that if you had side B here, you had angle A here, and then you had a side A, let's say located right here. Okay, what I'm trying to show you here is that as A is swiveling and it moves, it actually touches that one location at this spot right here, right? It creates that arc just like this. So what I'm basically trying to say is that that height of the triangle is basically equivalent to the value of A. And, well, how do we actually get height? Well, if it's a right triangle, notice that we can just use a little behind-the-scenes work of seeing that if we have angle A here, then sine of A You always want to use sine because sine will represent the height there. Sine gives you h over b. And so therefore h is equal to b sine a. Okay, so this value of h is equivalent to the value of b sine a. So if a is the same as the height, which is equal to b sine a, if this holds true, then what you end up seeing is that you only get one triangle formed, and that triangle happens to be a right triangle. Okay, so this is scenario 2, just like that. Okay, and then going now to scenario 3. If I were to draw the diagrams again, so here we have angle A, here we have side B, and now I were to extend A just ever so slightly, so when it swings and it creates that pendulum, what you end up seeing is that you can get two triangles that are formed right here, right? One on the right side and also one on the left side, just like that. So you'll see that A is actually going to be greater than the value of B, right? And we see that you can get two triangles here. In this case, you get two triangles. Okay? So that's when A is greater than B, just like that. But sometimes you might actually get a value where A is just extra large, right? It's even greater than the value. Sorry about that. No, it's not A is greater than B. It's actually A is greater than the height. The height being this part right here. That's when A is greater than the height. And remember that the height was measured, as we saw earlier in the previous example, as B sine A. So if A is greater than B sine A, we get two triangles formed. Okay, but we also have another scenario, scenario 4, in which that side A is just a little bit too long. That's when it's actually greater than the side of B that you see here. When A is greater than B, just like that, then you end up seeing that you get, again, only one triangle that can be formed here. When A is greater than B, you only get one triangle formed here. Okay? Just like that. All right. So those are basically the 4 scenarios I wanted to introduce to you. And in our next video, we're actually going to see how this is applied in solving some triangles.